All right, so here is the second half of your 3.2 video. We're going to talk about proofs. So a proof is a logical argument. Each statement in a proof is supported by a reason. So here's a list of what your reasons can be. Reasons can be postulates. Remember, another name for that is an axiom. They can be theorems, definitions, or properties. And so we'll get more into that as we go on. So this is called a paragraph proof. A paragraph proof is going to have some given information, what you're trying to prove, and then it's going to be a paragraph of information getting from what I've asked or what I've given you to what I've asked you to prove. We are not going to do paragraph proofs in our class very often. I'm never going to make you write one from scratch. And so I'm not going to spend a whole lot of time talking about this one today. So we're going to do, here's that same proof written as a 2-column proof. And so this is the type of proof we're going to do. And so right now this proof may also look a little bit daunting, but once we get started, I think that you'll be just fine. So again, you've got given information, what you're trying to prove, and then your 2 columns for the 2-column proof are labeled statements and reasons. You always start with your given information. So you'll notice I literally copied this from given, and I told you I know that because it's given. And then your proof statement is always the last thing, because you know you're done with the proof when you've proved what it's asked you to prove. Okay, so we only had to come up with 3 things right here. And again, we'll work through one together. So today specifically, we're just going to be looking at algebraic proofs just as a starting point before we jump into geometric proofs in later lessons. So here it goes. I'm going to draw a 2-column proof. I've got my statements and my reasons. My given information is the equation 2x plus 18 equals 6, and that is my given information. You're always going to start your proof off like that, so you should never miss this first part. Okay, now I'm ready to solve. This is just an equation. You know how to work an equation. To begin to isolate the variable, we're going to subtract 18 on both sides. If I do that, it will look like this. 2x equals negative 12. And since I did subtraction on both sides, my reason is going to be the subtraction property. Okay, again, it's subtraction if you do it on both sides of the equal sign. All right, step 3. Again, I'm trying to get the x by itself. I need to get rid of the 2, so I'm going to divide by 2 on both sides. I get x is negative 6. I did it on both sides of the equation, so that is the division property. That's it. I'm done. I solved for x. I showed every step. Okay, let's do another one. Look at this one. So this one is a little bit more complicated. We've got some variables. We've got some line segments. It's not just saying solve for x. So here we go. I'm going to start with my 2 columns. I'm just going to label them S and R this time. So your first reason is always your given information. Your given information is always all the stuff between the if and the then. Okay, so given is between if and then what you're trying to prove is always after the then. Okay, so I'm going to copy down all of my given information as my first statement. AB equals CD. AB equals 4x plus 8. And CD equals x plus 2. Again, that's all my given information. All right, now I'm ready to work through my problem. So now you just have to think about it. I notice I know that AB is equal to CD, and I have expressions for AB and CD. So I'm going to just replace that information. Instead of AB, I'm going to write 4x plus 8 equals, and instead of CD, I'm going to put x plus 2. So my second reason, the reason why I did that is the substitution property. We talked about that a little bit in our last video, that if you replace something with something that it's equivalent to, we call it substitution. Now I just have this equation I'm ready to solve. I like to take the x over to the 4x, so I'm going to do subtraction. My equation will now look like, messed up. 3x plus 8 equals 2. I did subtraction on both sides, so that's the subtraction property. I'm going to move the 8 to the other side. So I did subtraction on both sides again, so that's still the subtraction property. And my last step is going to be to divide by 3. Again, I did the division on both sides, so I can call that the division property. I know I'm done because I got x equals -2, and that's what I was asked to prove. All right, last one. And then we'll be done with proofs for today. So this one, prove that if volume equals 1/3 pi r squared h, then height equals 3v over pi r squared. So same situation. I'm going to do statements and reasons. My first statement is always given, the stuff between if and then. V equals 1/3 pi r squared h. That's my given. And what you're trying to prove is always after the then. So I know I'm going to be done with this problem when my final statement looks like this. All right, I notice in my final statement the fraction, the 1/3, is gone. So I want to start by getting rid of the 1/3. That's just a personal preference. I would prefer not to work with them. I know to get rid of 1/3, I can multiply my whole equation by 3, and it would turn into this. Since I multiplied both sides, I can call that the multiplication property. All right, I'm trying to get it equal to h. So I want to get the h by itself. The h is being multiplied by pi r squared. So I am going to divide on both sides. 3v divided by pi r squared is equal to h. Since I did division on both sides, I can call that the division property. Now, is this exactly what I've been asked to prove? No. It's pretty close, but it is on opposite sides. So I am going to rewrite it to where it says h equals 3v over pi r squared. Since I flipped it around, that, remember, is called the symmetric property. We talked about that in our last video. We said that if you're solving an equation and you get x equals 5, it's the same thing as 5 equals x. Okay, so again, that is the symmetric property. Now I'm finished because I've got my final statement is equal to what I was trying to prove.